Okay guys, here's video 2. This is for the functions quiz for unit 6 that we have soon. So let's take a look. We need to figure out where the local mins and maxes are for our graph. So I'm going to go back to my y equals and I'm going to type in my function. This would be a calculator problem. It would be a non-calculator problem if we gave you the graph and we just asked you to approximate values. So for our local max, first let's type in our function. So x to the 4th minus 4x cubed. Make sure you guys can see that okay. Minus 4x squared plus 16x. Okay, before we do anything, when I saw this, I noticed every single term has an x in it. So that means one of my zeros is going to be 0, because if I put 0 in, every single term will become 0. So that's just something I noticed when I was looking at it. Okay, let's graph this and see what happens. Oh, see, look, there's that 0, 0. Okay, if we want to find a max, that's going to be my only local max, because on these two ends it's going to keep going up for forever. So let's do a second calc. There's my max. Luckily, I'm pretty close. So there's my left bound. Here's my right bound. There's my guess. So I'm going to have a local max at approximately 1,9. See that again? It's practically 1, so we're going to call it that. We don't know for sure if the calculator is just being silly, but I will allow for a 1,9 on this, because even if we did round to the thousandths place, it would still be 1.000. Okay, now we've got to do our mins, but the problem with the graph the way it is we can't actually see our minimums. They go off the screen. So I'm going to go to my window, and let's make my y min negative 20. There they are. So let's do a second calc. Oopsie, second calc min. I'm going to scroll over. So my left bound. I'll scroll over to the right. There's my right bound. And I'm going to go to the bottom and take my guess. And that local min is going to be at negative 1.236, comma, negative 16. And then I've already done the other one. So I'm just going to write it down for now. I think you guys can figure out how to find that. Okay, for a point of inflection, we said all we're going to do for right now, oh, sorry guys, I have to graph this, don't I? I'll go back and do that in a minute. So our point of inflection is going to be about halfway between our maxes and our mins. Actually, you know what, I might as well plot this now. So really quick, 1, 9, there's my 9. Then I have negative 1.236, negative 16. So roughly there. We didn't need our zeros, but I know I have a 0 here. We'll call that good enough for now. If I did want to look, it looks on my screen as if it's crossing at approximately negative 2, and then also again at 2 and 4, it looks like. So if you want to use those to help you, you can. Let's see if I can make my nice long skinny graph now. So it's not perfect, but that gives us a good idea of what's going on. Okay, remember, a point of inflection is when it changes from concave up to concave down. So if I were to look at this, the way we've been approximating is we say our concavity change is going to be halfway between a min and a max. So my max is at 1, my min is at negative 1.236. So in my calculator, I'm going to say let's take an average of those. Let's divide by 2. And that's going to give me my approximate x coordinate for my point of inflection. It's right halfway in between the min and the max. Not the actual value, but it's a close enough approximation for right now. In calculus, you'll learn how to find the exact value. Well, if I go to my table and I plug this value in, that's going to give me the y value that's associated with it. So negative 1.937. So now I'm going to do it on the other side. I'm going to take an average of 1 and now this here. So my x value for my other point inflection will be this. And then if I go back to my table, I'll plug in 2.118, and that will give me my y value for that point of inflection. Because remember, we actually have to plug it in to figure out its y value. So my point of inflections are approximately here and here. So those are approximate. Those are my points of inflection. Trying to see. That looks pretty good. Okay, so interval of increasing. So we're increasing. Well, let's actually just start from here. From negative infinity all the way down to our minimum, we're decreasing. So from negative infinity up to our first minimum, where our first minimum is here. So we're going to go to negative 1.236. Okay. Then from there all the way up to our max, we're increasing. Okay. Then from our max down to this, we're decreasing. Well, then from that bottom, that minimum, and then forever on, we're increasing again. So there's my intervals of increasing and decreasing. So now I'm going to do my concavity intervals. Well, this is a smile, right? So all the way up into my first point of inflection. Oopsies. Oh, sorry. Nope, no, I was good. Sorry, concave up, it's smiling, right? Point of inflection, I'm concave up. But then from my first point of inflection to my second point of inflection, I'm concave down like a frown, right? And then starting up again from my next point of inflection, all the way till infinity, I'm concave up again. Okay. Ooh, that was fun, wasn't it? Okay, let's keep going. Down here it says, what is the degree of f of x? So now we're on number 17. Well, the degree is my leading term's exponent, right? So it's a degree of 4. What is the end behavior? Okay, well, this is a degree of 4, which means it's going to be even. So it means if I'm going up on one side, I'm going up on the other. If I'm going down on one side, I'm going down on the other. My leading term is negative. So if I were just to do a really brief sketch, that means that it's going to be facing down on both ends, right? And because it's even, again, since it's going down on one side, it's going down on the other side. So as x goes to positive infinity, as I'm going this direction, my function is going down. So I'm going towards negative infinity. As my x values go towards negative infinity, my function is also going down. Okay. It says, is the symmetry of my function even, odd, or neither? Show my work. Well, I need to plug in values. So the easiest way to do this is to say, let's plug in negative x into my function. So I'm going to have negative 4 times negative x to the 4th minus 8 negative x squared plus 3. If I take a negative x to the 4th root, that negative is kind of just going to disappear in a sense, because anytime you have a negative times a negative times a negative times a negative, they're going to all undo each other. Same thing here. A negative x squared will just be a positive x squared plus 3. Well, since this thing matches my original function perfectly, I'm going to have even symmetry. Okay, last one together. It says find the inverse of each function. State the domain and range of the original function and the inverse. So here's my function. Remember, the easiest way to solve is we're going to switch our x's and our y's. So I'm going to have x equals the square root of y plus 3. I'm going to subtract 3 on both sides. I need to square both sides. So I'm going to get y equals x minus 3 squared. If you want to leave it just like that for now, you can. Well, let's deal with our original function first, because this is going to have a restriction because of that square root. So notice x can never be less than 0. So I start at a value of 0, and I can go to infinity. So if I were to just sketch this really quick, it's going to look kind of like this, right? It got shifted up 3, so my range is going to start at positive 3, and we're going to go to infinity. Now remember, when we have an inverse function, our domain and range are literally just going to switch. Now, I'm aware that this function here, as it looks, is going to go on forever in both directions, or meaning there's no domain restriction. But remember, when we graph it, it's going to reflect across y equals x. So we need our inverse function to kind of do this. That seems a little wonky. I think I might have made a mistake. Oh no, we're good, we're good. Yep, so notice it's going to start at 3 and it's going to keep going this way, right? And then it's going to keep going up. So starting at a y value of 0, and then it'll keep going up. So that's what our inverse function will look like. Sorry, when I was looking at it, I got a little confused. Because we, in order for it to mirror perfectly, it's going to have to start in the same mirrored place. So there is number 20. So if you guys have any questions, we can go over this next class. There's also a key up on Blackboard for you that I posted. It's a little different than this one. That's why I paused at one point. So just take a look at this one, and I'll see you guys tomorrow in class.